In this session, I will start discussing about the matrix multiplication. In the last session, we have discussed about how to identify the symmetricity of matrix. Therefore, we have first discussed about the obtaining the transpose of matrix, and hence we have identified a method to obtain a method to identify the symmetricity of a square matrix. And today we will start this session from starting from the matrix multiplication. Suppose that if you have given two matrices, let the matrices as we'll say one matrix is named as matrix A and the next matrix is given as matrix B. Suppose that if you need to take the multiplication of these two matrices, it means that simply if you need to take an answer for this quantity, or if you need to take a value for this multiplication of matrix A with multiplication of matrix B, first you have to check whether these matrices are confirmable for matrix multiplication. To check that, what you have to do is, this is the condition that should be satisfied. The number of columns in matrix A should be equal to the number of rows in matrix B. Therefore, always if you have given the matrix product, or if you ask to find out the matrix product, here you are asked to find out the matrix product AB. Therefore, this will be your first matrix and B will be your second matrix. Therefore, number of columns in first matrix should be equal to the number of rows in second matrix. Therefore, this is the condition which should be satisfied. If this condition is satisfied, then we say that the matrices are confirmable for the matrix product AB. In here, I will, if you consider about this matrix A and matrix B with this given order, suppose that matrix A is with the order of m by n, and suppose B is a matrix having the order n by p. If you suppose to take the matrix product AB, first you need to check for the condition. It means that number of columns in first matrix should be equal to number of rows in second matrix. In here, you can see that number of columns in first matrix is equal to n and number of rows in second matrix is equal to n. Therefore, in this case, what we can identify is, we can see that uh, the condition is satisfied. Therefore, we can say that AB are confirmable for matrix product AB. Therefore, we can define the matrix product AB, and hence we will get the dimension of the matrix product AB as m by n. Therefore, if the matrices are confirmable for matrix multiplication, the number of rows of the resultant matrix is coming from the first matrix, and number of columns for the resultant matrix is coming from the second matrix. Therefore, this is the pattern we can see. Number of rows is coming from the first matrix, and number of columns, here this should be n by p. This should be corrected as n by p. This is m by p matrix. Order is n by p. Here it is given as well. Therefore, the number of columns of the resultant matrix is obtained by the number of columns of the second matrix. Therefore, this is how we can take the matrix multiplication. But anyhow, prior to this matrix multiplication, what you need to check is whether the matrices are confirmable for matrix multiplication or not. If the matrices are confirmable for matrix multiplication, then we can go for the matrix multiplication of such matrices. Okay, now if you move for the how we can get the matrix multiplication, if you can see that matrix A is given as, suppose that matrix A is given as, here I have used the general notation. It is given as Aij, where we are having this m number of rows and n number of columns. And suppose that matrix B is given as, it is B. Here I will take the letters as Bij, where is the general notation we are using. Here we'll take number of rows and columns as n by p. Therefore, if you perform this matrix multiplication, then for getting the matrix product AB, you will get this matrix product by taking the summation where k goes from 1 to n, a I times k, a I k times b, k times j. Therefore, using this equation, we can take the matrix multiplication of the matrix A and matrix B. But anyhow, in this session, I will not going to explain about how to get this calculation. Therefore, you can just write down this matrix in this form. Suppose you are having this as matrix A11, A12, likewise here you will get this as A1n. Similarly, it is A21, A22 up to A2n. Likewise, you will get this as AM1, AM2, likewise AMN. This would be your first matrix and this would be the second matrix. Here you will take this as B11, B12. Likewise, you are having p number of columns there. Here it is because n rows and p columns are available in this matrix B. Therefore, this would be B1 times p. Likewise, you can take this as Bn1, Bn2. Likewise, you can get this as Bnp. Now, suppose that if you need to take the matrix multiplication in the next stage, I will tell you how we can get the matrix multiplication. Therefore, once you use the technique of matrix multiplication appropriately, then you will be able to get this equation. Therefore, you can try it by yourself whether you can get this summation or just you can get this equation, or just by expanding this with the matrix multiplications we can identify this matrix multiplication. Okay, now we will see how we can perform the matrix multiplication. Here I will take this example as given in the note. Here I have taken two matrices. Suppose clear this. Suppose that I have used this matrix A. Matrix A is given as this is the first matrix I am considering. Here it is A1 1, first row, first element, first column element. Then likewise A1 2. I will take here three columns. Matrix A has having three columns. Then A21, A22 with A23. Therefore, we can see that matrix A is a 2 by 3 matrix, and matrix B is supposed to be given as it is given as B11, B12, B13, B21, B22, B23, 321. Here it is supposed that matrix B is a 3 by 3 matrix, 3 rows and 3 columns. Now, if you ask to take the matrix product AB, first you need to check whether you need to check whether the matrices are conformable for matrix product AB. First, you need to check whether this can be obtained. First, you can write it matrix A having the dimensions 2 by 3 and matrix B having the dimensions 3 by 3. If you check the number of rows and columns of this matrix, now what you can see here is here you can see that number of columns of first matrix is equal to number of rows of second matrix. Therefore, we can say that A and B are conformable for. So we can say that A and B are conformable for matrix multiplication. For matrix product AB. Matrix product AB. Therefore, this is the first step. What we are going to identify whether whether these matrices are conformable for matrix product AB. and thereafter we can move for obtaining the answer on this. Therefore, what you have to do is first you have to select the rows from the first matrix and columns from the second matrix. It is quite simple in this way. Suppose that you are selecting the first row. I will just select the row and column. Here I will select the first row of the first matrix, and here columns are selected from the second matrix. Now I have selected the first row and first column. It means that I will take, if I multiply the first row with the first column, then I will get the element at the first row, first column. Therefore, this is the element that I will be able to obtain by multiplying the first row of the first matrix with the first row of the first column of the second matrix. Therefore, if I need to take this element, what I can do is I am multiplying the first element with first element, second with second, and third element with third element, and then I am taking the summation of those cells. Then I will take this, I will get the answer as A11 multiplied with B11. Here I will get this as A11 multiplied with B11. Therefore, I can say that here this is A11 multiplied with B11. Then I am getting A11 times B11. Then added this to A12 multiplied with B21. That is how I am getting A12 with B21. Then A13 multiplied with B31. That is how I am getting the first element. Therefore, summation of these three products gives the element of the first row, first column. Since I have finished the calculations with the first column element, then I have to move for the second column. Since I have not finished all the columns, I'm still in the first row, then only I'm changing the column. Then I will get I am multiplying the first row with the second column. Therefore, I will get the element at the first row, second column. Therefore, we can easily get the element at this point, or element at this location. Therefore, same as previous, first element multiplied with first element, second element multiplied with second element. Therefore, I will get A11 multiplied with B12. That is how we are getting this element. Then this is added to A12 multiplied with B22. Then I'm getting this element. Then multiplying with A13 with B32. Then I'm getting this element. Therefore, I have to take the summation of all these three values to get the first row, second column elements. Likewise, now since we have finished the second column, then I can move for the third column, but still I am at the first row since all the columns have not finished yet. Therefore, in here I have selected the first column, still in the first column, but selected the first row, but selected the third column. Therefore, if I am using the same method, then I will get the first value as A11, B13. Multiplied these two elements, multiplied this element with this, then I will get A11 multiplied with B13, then A12 multiplied with B23, then A13 multiplied with B33. Therefore, the summation of these products give us the element at the first row, third column. Therefore, we are getting the element at this point. It is the first row, third column element. Now we have multiplied the first row of the first matrix with all the columns of the second matrix. Now what we can do is we can move for the multiplication of the elements in the second row of the first column. Therefore, what I am going to do is I am now going to select the second row of the first matrix. Therefore, I am starting the calculation at this point. Therefore, I am then selecting the first column of the second matrix. Then, using the same way, I can obtain the element at the second row, first column. Second row, first column element. Therefore, if I see the elements that I'm multiplying, A21 multiplying with B11, A22 multiplying with B21, A23 multiplied with B31. Therefore, first element with first element, second multiplied with second element, third element multiplied with third element. It gives the summation of these three quantities, and it will result the element at the second row first column. Similarly, since we have finished the calculations with the elements of the first column, now we can move for the second column of the second matrix. Therefore, we can consider this column. Then we can get this quantity or the quantity in the second row, second column. Using the same concept, we can obtain this value, and thereafter what we can do is we can since we have finished that calculation, then we can move for the third column as well. Therefore, it results the element at the second column, second row, and the third column of the resultant matrix. Therefore, this is how we are calculating, or we are obtaining uh, the multiplication of given two matrices which are confirmable for matrix multiplication. When we are discussing the concepts in algebra, what we have learned was simply, if you are taking 2 multiplied with 3, this is generally equal to 3 multiplied by 2. This is the general thing that we know when we are dealing with algebra. We know that multiplication of two values, if we are changing the order of the multiplication, then we will get the same result. But once you come to the concept of the matrix multiplication, here we'll see that A multiplied with B gives us the matrix product AB. This is not generally equal to the matrix product BA. Therefore, this is for the matrices. For the matrices, this equality does not exist, but in algebra, we can see this equality, but it is not true for the matrices. But here we are saying that in general, we are saying that AB does not equal to BA. It is because there is a situation where we are getting the product AB equals BA. When we are discussing about the inverse of matrices, we can say that if B is the inverse of matrix A, then we can see this equality satisfies. For any other cases, we can say that even though matrices are confirmable for matrix product, we are saying that AB in generally does not equal to BA. Therefore, this is the next thing you have to keep in your mind when we are dealing with the matrix multiplications. And thereafter, we will move for an example related with this matrix multiplication. Here we'll see how we can perform the matrix multiplication if we are having the numeric values. Suppose you have given the matrix A in the form of a 2 by 3 matrix having the elements 3, 2, and 1, 4, 5, and 6. This is a 2 by 3 matrix, and matrix B is supposed to be a 3 by 3 matrix having the elements 1, 2, 0, minus 1, 0, and 3, then 3, 2, and 5. Here you can see that this is a 3 by 3 matrix, and here you are asked to obtain the matrix product if it is possible. Or first, what you need to do is you need to check whether the matrix product exists or not. It means that these two matrices are confirmable for the matrix product or not. Then what you are doing is, first you can write down the this dimension of the matrices. Then you can see that the number of columns of first matrix is equal to the number of rows of the second matrix. Then we can say that A and B are confirmable for matrix multiplication. And we can say that A and B are confirmable for matrix product. AB. Therefore, what we can do is now we can identify the value. It means the dimension as 2 by 3 should be our resultant matrix. Therefore, now we can say that since the matrices are confirmable for matrix product, now we'll write down the elements. Matrix AB would be here, it is 3, 2, and 1, 4, 5, and 6, and thereafter we'll get this 1, 2, and 0, minus 1, 0, and 3, 10, 3. Okay, now we have to use the concept that we have used previously. Here first what we need to do is first we need to select the row and column. It is always starting from the first row of the first matrix multiplied with first column of the second matrix. If you perform this calculation, you can see here it is mentioned 3 multiplied with 1, 2 multiplied with minus 1, 1 multiplied with 3. Therefore, using this calculation by this addition and multiplication appropriately, and the next thing I would like to highlight here is when you are writing down this here, you are writing the first row, first column element. Therefore, it is better to use the brackets for this calculation. It will make really easy the calculation for you. First quantity is given by 3 multiplied with 1. Then this is added to 2 multiplied with minus 1. This is added to 2 multiplied with minus 1. Then this is added with the 1 multiplied with 3. Therefore, it would be better if you can write down this way. Therefore, this results the value as plus 4. Here you can see value is given as plus 4. Here the value is given as plus 4. Now you can see it. See, likewise we can perform now, since we have finished the calculation with the first row, with the first column. Now we can move for the second column of the second matrix. Then we have to select the second column of this matrix. Therefore, first row multiplied with second column, this you can see that it results the value in first row, second column of the resultant matrix. Once you perform this calculation, then you will get the value as plus 8. Then what we have to do is, since we have finished the calculation using second column, then you have to move for the third column. Then 3 multiplied with 0, 2 multiplied with 3, and 1 multiplied with 5 results these three quantities, and summation of these three quantities results the value as plus 11. Therefore, now we have finished the multiplication of all the columns with the first row. Now we have to move for the second column of the second row of the first matrix. Now, so in a similar way, what you have done previously, select the first row, first column, and obtain the value. Here you can see it is obtained as 17. Then then you have to move to the second column and you have to obtain the value. Likewise, you have to then move to the third column and then you have to obtain the value. Now, if you go through the answer which has obtained, here you can see that this results the answer for the matrix product AB as 4, 8, 11, 17, 20, and 45. Therefore, multiplication of these two matrices results the answer as 4, 8, 11, 17, 20, and 45. In the previous one of the previous sessions that we have discussed about the scalar multiplication. Now you can see that what is the difference between the scalar multiplication with the matrix multiplication. It's because in the scalar multiplication, what we have done was we have multiplied each and every element of the given matrix by the given scalar. But when we are multiplying two matrices, it is a different concept with compared to the scalar multiplication of matrices. Here, if you try to find out the matrix multiplication, suppose that here we have identified that AB is confirmable for matrix multiplication. What will happen if you are trying to identify the identify this product, matrix product BA. In here, if you are trying to identify the matrix product BA, now if you see the dimension of matrix B, it is given as a 3 by 3 matrix. And now your second matrix is matrix A, it is a 2 by 3 matrix. Now if you consider about the matrix multiplication, number of columns in first matrix and number of rows in second matrix, then we can see that the condition does not satisfy. Therefore we can say that A and B are not confirmable for matrix product BA. Therefore we can say that A and B are not confirmable for the matrix product BA. Here we need to identify this first. Therefore we can say that this is not possible. That is why at the beginning also I told that in generally AB does not equal to BA. This is in general. In general we will have this inequality, but in the algebra we can have this AB multiplication is equal to BA multiplication as well. But for the matrices, this is the concept we are following. And there is an exercise given for you. You can try this by yourselves. Here A and B are given as 2 by 2 matrices, both are 2 by 2, and here you are asked to obtain the matrix product AB and matrix product BA. And even though we can obtain both products, you are asked to check whether the matrices are equal, or these matrix products are equal or not. Therefore first for the first part, you can use the matrix multiplication and you can obtain matrix AB and matrix BA, and thereafter you can use the concept that we have discussed under the equal matrices. Using the concept of equal matrices, you can check whether these two results are same or not. And now we will move for the next part. It is the determinant of a square matrix. When we are discussing about the matrices, we have discussed, or we have learned that a square matrix is a special type of matrix which is having equal number of rows and columns. When we are considering about the square matrix, each and every square matrix is associated with a real number. Each and every square matrix is associated with the real number, which is called as the determinant of that matrix. Therefore, when we are going to identify the determinant for a square matrix, what we are going to find out is we are going to find out the real number associated with the given square matrix. When we are going to identify the determinant of a square matrix, here we will discuss two methods. First method is only applied, which can be only applicable for 2 by 2 matrices, and for 3 by 3 matrix we will discuss a general method. But we are not going to discussing about the identification or obtaining the determinant of square matrix which is having the higher orders apart from this 3 by 3 matrices. Therefore, up to 3 by 3 matrices, we are discussing about the obtaining the determinant of matrices. Therefore, as the first case, we'll see how we can obtain the determinant of a 2 by 2 matrix. But prior to discuss this matter, I told you that if you are having a matrix, square matrix as matrix A, then this is associated with the real number, which is called as the determinant of this matrix. Therefore, we can write down, or we can denote the determinant of the matrix as determinant of A. We are general writing this as determinant of A, or else we are writing this inside the modulus notation. Here we will take this as we are using this notation as well to denote the determinant of matrix A. Now suppose that you are having a 2 by 2 matrix given as the matrix A. Suppose that you are having a matrix A given in this form. You are having, it is a 2 by 2 matrix, A, B, C, and D. This is a 2 by 2 matrix, 2 rows and 2 columns. And hence, if you identify, or if you are going to identify the determinant for this matrix, it is determinant of A, and it can be written in this form, determinant of matrix A. Therefore, first what we can do is, inside this notation, you can write down the elements of the matrix. First, you can write down the elements of the matrix. It is A, B, C, and D. And then we can take the difference of the diagonal products. Then what we can take here is, first we need to take the product of the main diagonal element. It is equal to AD. Then this is, we'll take this as the sum, the subtraction of the other diagonal. It is BC. AD minus BC suggests the determinant for this matrix. Therefore, we can say that for a 2 by 2 matrix, we can say it as the difference of the product of the two diagonals of the matrix. When we are obtaining the determinant for a matrix, this can be a positive value, or else this can be a negative value, or else this can be have the value as 0. Therefore, determinant can be determinant can be 0, determinant can be positive value, and determinant can be negative value. Therefore, all there are all three possibilities. But anyhow, if you are considering a determinant for a square matrix, it should be only a one real number associated with that matrix. Here I have included some exercise, and I will discuss it now. And in the here it is given three matrices. First matrix is given as matrix A. It is 2 minus 3, 1 and 2. Here this is a 2 by 2 matrix, and if you take the determinant of this matrix, we can write it as determinant of A, or else you can use this notation. First, what we are taking is, we can take the we can write down the elements inside this notation. It is 2 minus 3, 1 and 2. Then we can take the difference of the products of the diagonal elements. It means 2 by 2, it is 4, minus 1 into minus 3. Here it is 1 into minus 3, suggest the value as minus 3. Therefore, we will get this as minus into minus, it will become plus. And for the first one, we can take determinant of this matrix A is equal to plus 7. Here I need to say that in the for the matrix B, actually there is a correction which I should need to make here. This should be diagonal products. It is AD minus BC. This is AD minus BC. For this one, for the next matrix, here if I take the second matrix, here we need to take the determinant for matrix B. Then we can obtain this as here we need to take the determinant for matrix B. This can be written in this form, and we can write down the elements inside the notation. It is 2, 1, 4 and 2. Once you perform the calculation, 2 by 2, it is 4 minus 4 into 1, 4, which equals to 0. For the second one, we can see that value is equal to 0. And for the next one, it is for the matrix C. We can take the determinant of this matrix C in this form, 0, 3 over 2, 2 and 4. If you take the difference of the products of the diagonals, then 0 times 4 gets the value as 0, minus 3 over 2 multiplied with 2 gives the value as 3, which suggests the value as minus 3. Therefore, we can take the determinant of the matrix C is equal to minus 3. Therefore, we can use this technique to get the determinant for a 2 by 2 matrix. And now we will see how we can extend this method to obtain the determinant of a 3 by 3 matrix. We'll consider a 3 by 3 matrix in this form. Suppose that you are having a matrix A given as the elements, matrix A having the elements A1, B1, C1, A2, B2, C2, A3, B3, C3, which is a 3 by 3 matrix, a 3 by 3 matrix. And suppose that you are asked to take the determinant of for a 3 by 3 matrix. You can first write down these elements, and thereafter what we can do is first when we are going to identify the matrix of a 3 by 3 matrix, we need to stick into this procedure. First you need to write down, or you need to identify the value at the first row first column. Always we are taking the value at first row first column, and then we have to write it first. Here we will take it as value of a1. Then what we need to do is we need to cut down the row and column associated with that value. We have selected a1. Now we have to cut down the row and column associated with that value. Therefore we can see that the remaining elements are b2, c2, b3 and c3. Therefore these remaining elements should be written inside the determinant notation. Therefore I will write it here. The remaining elements are b2, c2, b3 and c. Now we have finished with the element with the first row first column element. Then I have to move for the first row second column element. Then once it is selected, we have to write it here. And as the last part, I will say how we can connect these terms. Now what we have identified was first row second column element was b1, and then we have identified this, then cut down the row and column associated with this value. Then we can identify the remaining values are a2, c2, a3 and c3, and then we have to write it inside the determinant notation. Therefore we can write these values inside the notation a2, c2 with a3, c3. And we have finished up with the element with the first row second column. Therefore I have to select the first row third column element. Once I select the first row third column element, it is c1. Then using the same procedure, cut down the row and column, and remaining elements has to be written inside the determinant notation. Therefore we will get this as a2, b2. We will get this as a2, b2, a3 and therefore these are the three terms that we are getting. And now we need to connect these three terms. Therefore always we are starting with the plus sign, starting with plus sign here. Then minus sign is used to connect the second term with first term, and then the third term is connected with second term by using a plus sign. Generally we are not going to worry about this initial plus sign, that is why we are not going to include it here. But anyhow the concept is used as plus, minus and plus. Therefore using this theory, now you have reduce this 3 by 3 matrix with some two with the some 2 by 2 determinant of 2 by 2 matrices. Therefore now we can use the same concept that we have used previously for 2 by 2. Now you can see inside this determinant notation, here we can see only uh, the, the elements for 2 by 2 matrices. Therefore we can get this value as, here it is a1 times b2 multiplied with c3. Then this gives the b2 c3 minus b3 c2. Then this minus b1 times a2 c3 minus a3 c2. Then this is added to c1 times a2 b3 minus b a3 b2. Therefore this is how we are taking the determinant for a 3 by 3 matrix, but it is no need to memorize this type of equation. What you have to be familiarized with the technique that we need to use to identify the determinant for 3 by 3 matrix. Therefore, yeah, now here I have included an example related to obtaining determinant of 3 by 3 matrix. Here actually the three problems have given, but I will just use one problem to explain how to take the determinant of a 3 by 3 matrix. Here I will take the first problem to discuss or explain about how to obtain the determinant for a 3 by 3 matrix. Suppose that we are having the matrix A. If I write down the elements of this matrix, here it is 5, 7, matrix A having the elements 5, 7, 3, 4, 8, and 2, 4, 6, and 3, and this is supposed to be a 3 by 3 matrix. To take the determinant of this matrix, what we have to do is first we need to select the element and cut off the row and column associated with that. First we are selecting the element in first row, first column, and then we have to cut down the row and column associated with that value. Since it is in the first row, first column, I have to cut down the values associated with that row and column. Then I have to write down the values in this way to take the determinant of this matrix. First, I am writing the value of 5. Then I am taking these values 8, 2, 6, and 3. Here it is 8, 2, 6, and 3. Then now I have to move for the second column of this matrix. Therefore, again, I have to select the value. The new value is plus 7, and we have to cut down the row and column associated with that value. Row and column value is 7. Remaining values are 4, 2, 4, and 3. And then we have to move for the next column. If you select this value, it is plus 3. Then we have to cut down the row and column associated with this. Then we can get the value as it is 3 times the quantities are 4, 8, 4, 6. Now we have to connect these terms using the notation plus, minus, and plus. Therefore, we'll add these signs plus, minus, and plus. This is using a concept, theory. As a theory, we are using this concept. Therefore, always we are allocating plus for the first one. Then we have to use the opposite sign for the second one and opposite of that sign for the third one as well. Then what we can get here is, here it is 5 times, then 8 times 3, 24 minus 6 times 2, 12 minus 7 times 4 times 3, 12 minus 4 times 2, 8, plus 3 times 4 times 6, 24 minus 4 times 8, 40. Now performing this calculation, we can obtain the answer. Here you can see the answer was obtained as here it is, there is a correction as well. 4 times 8, it is 32. For performing this calculation, you can obtain this value is equal to plus 8. Okay, therefore this is the way that we are performing the calculation, and I will use another example to explain explain the use of the sign pattern. Therefore, if I use this example, suppose that we are having a matrix in this form. Suppose that you are having a matrix having the elements. A is supposed to be a matrix having 5, -7, -3, then 4, 8, 2, 4, 6, and 3. Suppose that this is the matrix we are having, and then what we need to do is we need to obtain the determinant for this matrix. Therefore, using the same concept, we have to use the first value here is taken as 5. Then cutting down the row and column, we can write down the values as 8, 2, 6, and 3. Then we have to select this value, it is -7. Then if you cut down the row and column and write down the values, it is 4, 2, 4, and 3. Then the next value is -3. When you're writing down these values, it is better to write them inside the brackets. Then since you are having -3 here, it is 4, 8, 4, and 6. 4, 8, 4, and 6. Now what we need to do is we need to connect them using the sign pattern. Even though we are having the signs inside in front of these values, these are the signs associated for that value or the element at that point. But you cannot use those signs or these notation signs to connect these terms. Always we have to use the concept. Here we are using plus, here we are using minus, here we are using plus sign. Now we can take this multiplication. It is 5 times. Here it is 24 minus 12. Then here it is minus into -7. This is what we are having. Then it is 4 times 3, 12 minus 8. Then here it is plus with -3. 4 times 6, 24 minus 4 times 8. Then this results the value as 5 times. Here we will get the value as 12. Then minus into minus, it is becoming plus 7 times 4. Then this value becomes minus 3 times 8. Plus into minus. Therefore, we'll get this as 60 plus 28 minus 24. Therefore, this results the value as 64. Then this is how what we can do, what we have to do if you ask to obtain the determinant of a 3 by 3 matrix. And this is all what I need to discuss in this session, and thank you all for participating with this session.